This is a neat pair of pictures. What you're seeing on the left here is a combination of two different data sources. It's Landsat data, most of the area, but you see my pinky finger is pointing these red areas. The red areas are from a sensor called Aster, also on the Terra satellite, that can actually directly detect heat from things like forest fires, but also from volcanic eruptions. And in this case, this volcano actually erupted, sending a lava flow through the city of Goma, Democratic Republic of Congo, formerly known as Zaire. This is a city of around 250,000 people, and lava flows went straight through the center of town. Now, you see the yellow lines here. If we take that area and we zoom it up, this is from that Eros-A satellite. This was taken several months later. The dark area shows the cooled lava, so you can walk around on it. This is the runway for the airport. Just missed the end of the runway there. Okay, but it's not the most accessible part of the world, and so there wasn't a lot of media coverage of this, but it was one of the rare cases where you actually had lava actually flowing through a large city. And these kinds of images are good for instance, mapping where things are affected and where they're not. Also happens with floods. This is a neat combination of data from the SPOT satellite and the Landsat satellite. The different colors show different kinds of land cover. So the yellow colors that you see are loose sand. Those are sand dunes in the upper half. The lower half, there isn't as much loose sand. It's more of a rocky texture to the land. And this is near the border between Yemen and Saudi Arabia. This is Mount Kenya. This is the second tallest mountain in Africa. Kilimanjaro, which is slightly taller, is just to the south here. Remember what I said about that bright red color. Mount Kenya is not red. The bright red here indicates a very strong reflection in near-infrared light. Light we cannot see with our eyes, but it's reflected very strongly by the leaves of plants. So this tells us there's this band of vegetation around the mountain. What's going on here is that this mountain is very high, so as the air around it is forced up, the air is cooled, then it condenses, the water vapor condenses, so there's fairly somewhat more precipitation, so there's more vegetation there. Eventually, as the air gets up and over the mountain, the air becomes very dry. So you have this band of vegetation around the mountain. This is the McCarty's lava flow in New Mexico. A lot of people don't know it, but New Mexico is actually a very volcanic place. In fact, this is a relatively recent lava flow. It's only a few thousand years old, so almost certainly people were there to see it, which must have been an amazing sight. The lava came out of this area and then flowed north. The town of Grants is located right here. This is an image we actually used in the field work that we do in the department where I work, where we're actually trying to understand how lava moves and how it behaves and compare it to things that we see on other planets. But in this case, the dark black areas of the lava, and again, the red indicates the vegetated areas. Another thing that you notice when you look at all these images is everywhere you look, there's water, or in the case of ice, frozen water. This is on the left there, that's an image from Antarctica. But let's start with water. So North America is on the left. Here's Cape Hatteras, North Carolina right there. See the different colors in the ocean? The different colors here show different concentrations of chlorophyll in the ocean. As you know, plants on land use chlorophyll to absorb sunlight. That's how they do their photosynthesis. Well, in the ocean, there are countless of microscopic phytoplankton that do the same thing. They use sunlight to grow. And we can actually detect that signature from space. So we're looking at the concentration of chlorophyll in the upper meter or so of seawater. All right? And what we're seeing here, see how this area right here, there's a big change here. There's a big temperature change. Turns out that chlorophyll needs to eat nutrients, and the nutrients are suspended better in the colder water. But we got this band of warmer water here, which is the Gulf Stream. And sometimes little bits of water peel off, and we get these gyres right there. And they can last for weeks sometimes. It's a neat picture of the Lena River Delta. This is part of the exhibit as well. This is in the Lena River flows through Russia, and it empties into the Arctic Ocean. And again, the colors here are not real, okay, but this is an image that shows us the different densities of vegetation in this wetland area. And it's supposed to, again, and it's one of those protected areas, so we can use images like this to see where things are growing and where they're not. Here's a high-resolution image. This is Victoria Falls between Zimbabwe and Zambia. I say high-resolution because you can see here's individual buildings at a tourist rest stop, right? And this image right here was used mostly just for pretty pictures, but you can do things like plan roads around it and things like that. Actually, I'm going to skip that one for now and go right to this one. This is New Orleans, right after Katrina. Now, again, I said before, these images that detect changes are useful for things like seeing where things have been affected by floods in this case. Now, a little bit hard to see here, but you see these streets here, relatively bright color. See how it's a dark color all in here? It's dark because there's standing water there. This was just after. There's the Superdome with the roof peeled off. You can't see it on the screen here, but trust me, if you could zoom into this image, you can see the vehicles parked on the elevated highways that are kind of stuck there because they have nowhere to go. These kinds of images have become a lot more useful for disaster response. Okay? And it's easy to imagine the usefulness for that. If you need to get into a place, you can find an image and you can navigate around your area. This is also in Egypt. This is Cairo metropolitan area. See that gray area? But the bright red is agriculture, or mostly agriculture. And you can see the sharp contrast between the fertile Nile Valley and the desert on either side. It's really a surprising difference. And then talking about Egypt, here's the Great Pyramids in Giza. Another thing that you often notice looking at these kinds of images is people are everywhere, or almost everywhere. And it's actually kind of interesting and fun to see where people are and where they're not. And so here's a few examples of different things that people have built through the ages. Here's the Great Pyramids at Giza right here, and then you've got, it's behind the label here, but see that thing? Anybody recognize what that is? Yeah, see, if you look at these images, you're able to, that shape that I'm pointing at is really, you see it everywhere. It's a golf course. It's a very, you notice that everybody has golf courses. Pharaohs, yes, it's an ancient Egypt. It's not Scottish at all. It's an ancient Egyptian age. No, just kidding. Okay, this is New York City. Now again, this is false color, but it's a little bit closer. The bright greens show vegetation. So in this case, we've taken that part of the image that shows that infrared reflectant, all right, and we've made it green instead of red. I can make it whatever I want. And that's Central Park in Manhattan. See, Midtown Manhattan is sort of a darker color, and that happens because that's where the tall skyscrapers are. And skyscrapers cast shadows, right? So it reflects less sunlight up to the satellite. Yeah, good question. He's asking about what just happened, what was it, 2 days ago now, right? LaGuardia Airport is right there, and he used this, that aircraft was taking off this way along that, and it had and then took a left turn here and ended up right about here, actually. Yeah. He was not able to use remote sensing. He had to make faster decisions than that. This is Kansas. Now, what you're looking at, actually, why does it look like that? Circle pivot irrigation, yes. What you're looking at here are countless, well, it's not countless, but I don't want to count them, fields, agricultural fields that are irrigated using circle pivot irrigation. Okay, you've got a center and a big arm sweeps around and drips water, and it's a very efficient way of irrigating crops. It's so efficient that even if your land is square-shaped, the corners of your land are not useful, but you get more productivity out of the circle. Now, in this case, the dark red circles are areas where crops are growing, and the white circles are areas where either it's been harvested already or it's just fallow. And so you can actually do a count of how much acreage is being currently used for growing crops and how much isn't right now. And that's another primary, has always been an application of remote sensing for trying to detect things like crop yields. when you're trying to understand vegetation in forests, it's very complicated because forests are unruly, right? The trees are, some trees are tall, some trees are short, but when you're trying to understand agriculture, it can be a lot more simple, right? Because it's not unruly. I mean, the crops are in a nice row. So it's been used as an application for remote sensing since the Landsat satellites were launched in the early 70s.